Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, my name is Ahmad Afifudin Syakuri. My number student is 22513 049. I am from Department of Environmental Engineering, Islamic Indonesian University. In this opportunity, I'm going to present a summary of the article titled Assessing the impacts of climate and land use change on stream flow, water quality, and suspended sediment in the core river basin, Iran. I have divided my presentation about with four parts. The first, introduction, and then methods. The third is results and discussion. And the last one is conclusions. Introduction. In addition to climate change, land use activities such as conversion of natural landscape for human use and different land management practices have transformed a large proportion of Earth's land surface. Results show that climate change will cause dry hydrological conditions and increase river NO3 and concentration in some areas. It's important to examine the potential impacts of this change at the watershed scale, since both soil erosion and sediment delivery to river channels are affected by climate and land use change. The secondly is methods. I have divided methods by 7 parts. First, study area. The core river located in the Mahalupaktikan basin of Far province, Iran. This is important river in the region. The Dorazan Dam, built in the river, is crucial for uh, produce electricity production, agriculture, and industry. The river originates from the Zagros Mountains and flows for 280 kilometers before reaching Paktikan Lake. The basin has an average annual temperature and precipitation 17 Celsius degree and 240 millimeter. The core river is a study area with 2 meteorological and hydrometric stations in Dorozan, Taksi Jamshid, and Dorozan, Olehan. The majority of the inhabitants work in agriculture, with water from the river primarily used for irrigation. The major crops in the area are wheat, rice, and barley. The average utilization rate of phosphate and nitrogen fertilizer in 2008 was 184 and 342 kilograms per hectare per year. Secondly, basins and wind HSPF model. The Environmental Protection Agency, or EPA, created the Integrated Environmental Analysis System, or BASINS, basins to be used in assessing total maximum daily loads of pollutant and modeling the hydrology. WinHSPF employs several water balance equations to compute runoff on past and recent land surfaces. Precipitation and evapotranspiration data are the only hourly data that must be provided. Additional meteorological variables, such as maximum and lowest temperature, wind speed, and cloud cover, may also be reported. There are 3 main factors caused on the choice of this model for this study. The first is that Basin has an extensive user base and offers enough of case studies and technical assistance. The Hydrological Simulation Program Portal, or HSPF, is better to many other hydrological models in two ways. It allows for a thorough examination of long-term effects on both water quality and quantity, since it replicates loadings of a number of water quality elements in addition to hydrology. After that, I want to tell about model calibration and validation. Model in any model application, calibration and validation are essential steps. An iterative process of parameter adjustment is required to calibrate the HSPF, comparing simulated and observed values. This process requires years of simulation, which also take years uh, to make sure the calibrated model accurately examines variables and conditions affecting model results. Validation is an extension of the calibration process. For stream flow, sediment, and water quality simulation in the core river basin, the HSPF model was calibrated and validated. At the Polycan Stream Discharge Station, the model was validated for 2009 to 2012 and calibrated for 2003 to 2008. The model was deemed good in terms of R2 and Wilson differences. The calibrated model accurately describes stream flow, sediment, and water quality in the basin, indicating that it can be used to predict climate and land use change. And the fifth, land use change scenarios. According to previous research, agricultural land in the area increased by 1.6 times between 1956 and 2008. Other land use types will remain constant in order to increase agricultural land use by 60%, while the second most dominant land use category in the study area will decrease in sub-watershed. Last one, the method is combined scenario setup. There are three scenarios were defined in this study to evaluate the separate and combined impacts on stream flow, suspended sediment, and water quality. The following scenarios were created. 1. High climate change or LCP 8.5 agricultural development HCCLC 60. Second, number second, low climate change LCP 2.6 agricultural development LCCLC 60. And the last, high climate change LCP 8.5 urban development HCCLC 30. The next part is results and discussion. I have divided the content of results by 4 parts. There are calibration and validation and etc. First, calibration and validation. The HSPF model was calibrated and verified for simulation of stream flow, sediment, and water quality. The results show that the calibrated model can characterize stream flow, sediment, and water quality in the core river basin, and they confirm that the calibrated model with optimum parameters can be used to predict how the basin will respond to climate and land use change. Next, impact of future climate change. Temperature rises in all months except January for LCP 8.5, with greater magnitude in the summer. Precipitation was expected to increase greatly in the fall and winter months, but just marginally in the winter, spring, and summer months. The simulated finding for stream flow, suspended sediment concentration, ammonia, and orthophosphate concentration for the future period 2020 to 2049. Relative to the baseline period, seasonal stream flow more vividly demonstrates the effects of future climate change than monthly stream flow. There is a strong association between flow sediment and orthophosphate load and concentration for core river at Pelekan Hydrometric Station, calibration and validation. Because orthophosphate is strongly attracted to soil particles, it's significantly associated with sediment. Other investigations have found phosphorus is associated to suspended sediment and since suspended sediment concentration affect phosphorus concentration. And then impact of future land use change. Land use change such as urban growth and agricultural development have a significant impact on the quality and quantity of water resources. Stream flow decreased from January to September and increased from October to December under agricultural development scenario. Except for the winter months, there are no significant changes in stream flow under urban development scenario. Urban development reduces precipitation infiltration and increases runoff due to increased impervious surface cover. Then, impacts of climate and land use change. The effect of climate and land use change on total ammonia and orthophosphate, the change in total ammonia generally follows the pattern of climate change scenario. Because of the direction of change in the urban development scenario, the HCCLC 30 scenario had the greatest change in total ammonia concentration. This finding highlights the importance of land use change on nutrient change, as well as the strong relationship between suspended sediment and orthophosphate, which has been confirmed by previous results. The last one part is conclusions. The conclusion is there are three conclusions. First is this study looks at the effect of climate and land use change on stream flow, suspended sediment, total ammonia, and orthophosphate concentration separately and together. Secondly, the Bayesian's mean SPF model is used to predict future change in response to various climate and land use change scenarios. Hydrology, sediment, and water quality are calculated using the calibrated and validated model. Number three, according to the findings, projected climate change impact include increased stream flow and a decrease in suspended sediment, total ammonia, and orthophosphate concentration. The presented results are subject to the uncertainties that come with any scenario-based analysis. Our study excludes uncertainties associated with climate model output, downscaling method, and hydrological model. Okay, I just say it all. There are many my mistake, so that forgive me you all. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.